Throughout history, human beings have peered into the night sky and recorded the glowing lights that flicker and move above our heads. The first maps of the stars and the planets were drawn on the walls of caves, recorded as calendars, and tracked with astronomical symbols. Then, books and written records became the main source of information that expressed the way the people of that time thought of the cosmos. As technology, along with our understanding of the universe, became ever more sophisticated, more and more worlds in our solar system were discovered, and with that came the possibility of life beyond Earth. On the face of it, the galaxy looks to be eerily silent. We have not detected any signs of life as of yet. However, the search for life beyond Earth is really only just getting started. Even within our solar system, it is now thought to be a possibility that life could have independently sprouted up in a few different places. Europa, a promising destination for life. Orbiting the magnificent gas giant planet Jupiter is the mysterious icy moon Europa, a seemingly frozen world about the same size as our moon, with a surface temperature of about -160 degrees Celsius and a location that means it has to withstand a relentless pummeling of radiation. At first sight, it would be easy to think of Europa as a barren ball of ice. But despite the harsh conditions it exists within, this fractured moon is one of the most promising places to search for alien-like life. Many spacecraft have passed by Europa during their missions, but it was NASA's Galileo spacecraft that elevated our understanding of this icy moon to a new level. It discovered the first solid evidence that an enormous ocean exists beneath its surface, an ocean with possibly 2 or 3 times as much water as all of Earth's combined. Galileo confirmed that Europa was geologically active. Its close-up images revealed enormous cracks in the moon's surface, separated by dark icy material that had flowed into the open gaps. These cracks and the relatively young smooth surface suggested that Europa's icy shell is relatively young and that something had erased any large craters, such as icy volcanic flows. One of the most important measurements made by the Galileo mission showed how Jupiter's magnetic field was disrupted in the space around Europa. This measurement strongly implied that a special type of magnetic field is being created within the icy moon by a deep layer of some electrically conductive fluid. Based on Europa's icy composition, scientists think the most likely material to create this magnetic signature is a global ocean of salty water. There are even images from the Hubble Space Telescope that appear to show huge plumes of water vapor erupting from Europa's south pole. Although unfortunately, they are not high resolution enough to be definitive. If Europa's surface is frozen solid, then how could a massive ocean of salty water form? And if there is liquid water down there, could life have really started in such a bizarre environment? While the icy shell of Europa is frozen hard as rock, the interior is warmer because it is heated by what's called tidal flexing. The side of Europa that is closest to Jupiter experiences a stronger pull than the other side, stretching the entire moon back and forth. This constant flexing melts the eternal ice and creates Europa's enormous ocean. Life as we know it seems to have for main requirements liquid water, certain chemical elements, an energy source, and time. Europa may have an enormous ocean of liquid water protected below its crust, and certain studies suggest that it may have formed just a few hundred years after the moon formed, giving life, if it does exist there, plenty of time to get going. Chemical elements, the building blocks of life as we know it, include carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur. These elements are common throughout the universe and make up 98% of living matter on Earth. Scientists think these elements were likely present during the formation of Europa and may have even been added to later on when asteroids and comets collided with the icy moon. Life as we know it on Earth relies mainly on the sun for energy, but any life that may exist in the ocean of Europa is hidden below the thick ice, meaning that a process like photosynthesis couldn't work. Instead, life would have to be powered purely by chemical reactions. These reactions could come from Jupiter's powerful radiation bombarding Europa's surface or from the warm rock at the seafloor heated by tidal flexing. If Europa's rocky ocean floor is heated by tidal flexing, that process could potentially be supplying energy in the form of available chemical nutrients in hydrothermal vents. This is a process called chemosynthesis and is what ultimately powers entire ecosystems around hydrothermal vents found in the deep, dark regions of our oceans. So, life as we know it on Europa could be possible, but what might it look like? To get an idea, one place we could look is within one of the deepest, darkest points on Earth, the Mariana Trench. Dive deep enough and you will find some of the weirdest creatures on Earth. Take the snailfish, for example, a species that breaks the record for any living vertebrate. It is the deepest living fish ever discovered, found at more than 8,000 meters below sea level. This weird, translucent tadpole-looking fish is known to contain chemicals that help keep its membranes and cell walls flexible so that the crushing pressure doesn't kill them. But there are creatures that live deeper within the deepest region of the Mariana Trench, the Challenger Deep. 3 organisms are most commonly found: xenophyophores, amphipods, and holothurians. These organisms have adapted to survive in extreme conditions, and they provide insights into what life on Europa might look like if it exists.
Titan, a moon with liquid methane seas. Titan is a moon larger than the planet Mercury that is orbiting the ringed world Saturn. Below all that thick cloud, vast seas, lakes, and rivers have been discovered pouring over parts of its frozen surface. This is the only place in the solar system, other than Earth, where liquid flows across the surface. Although Titan is a truly mysterious place, it holds many secrets. Large bodies of liquid on Titan had been suspected since the Voyager probes passed by in the early 1980s, but it wasn't until the Cassini spacecraft visited in 2006 that they were actually confirmed. The lakes and seas on Titan are made up of liquid methane and ethane. And like the oceans of Earth that are made up of water, these lakes and seas, typically located in the polar regions of Titan, can be quite large, with some of the largest comparable to the Great Lakes of North America. They are also incredibly deep, with some areas estimated to be over 200 meters deep. The lakes and seas on Titan are thought to have formed from the breakdown of methane and nitrogen in its atmosphere over time. One of the intriguing questions about Titan is whether it could harbor life. Well, the lack of liquid water on its surface would mean that life, as we know it, which relies on water, cannot exist there. Some microorganisms on Earth have been discovered to consume and survive in hydrocarbons. The lakes on Titan are primarily composed of liquid methane and ethane, which are hydrocarbons. Life that could exist in these lakes would have to be adapted to living in an environment that is drastically different from Earth's. Scientists have hypothesized that Titan life could be based on a completely different biochemistry. Instead of relying on water as a solvent, these life forms could use hydrocarbons, such as methane and ethane. However, this would require a different cell structure for the organisms to survive. Unfortunately, there is no direct evidence of life on Titan. The only probe ever to land on its surface was the Huygens probe back in 2005. It captured stunning images as it descended and landed, but there is no indication of life. However, the complex chemistry and unique environments of Titan make it a destination for continued exploration. Proxima b, the neighboring exoplanet. Proxima b is an exoplanet located in the habitable zone of the closest star to the Sun, Proxima Centauri. Although it is likely being bombarded by radiation from its star, this neighboring planet could still be a promising place to search for alien life.
Proxima b is part of a triple star system, with Proxima Centauri being a small, long-lived, low-mass, cool red dwarf star. Being within the habitable zone means it is not too hot or too cold, and liquid water could exist on its surface. However, due to its close orbit to its small star, Proxima b is exposed to intense radiation and experiences extreme conditions. Earth climate models show that rocky exoplanets around red dwarfs can still be habitable. Simulations reveal that with an atmosphere similar to modern Earth and a strong magnetic field, Proxima b could potentially host life. The thick clouds on the star-facing side might act as a massive umbrella, deflecting even more of the star's radiation. With a combination of atmosphere and ocean circulation, warm air and water could move around the planet, maintaining regions with liquid water. However, it is important to note that Proxima b has never been directly imaged, and the information we have on the elusive exoplanet is very limited. Further exploration and research are needed to determine if Proxima b is a world capable of supporting life. Conclusion: as we continue to explore the outer reaches of our solar system, worlds like Europa, Titan, and Proxima b remain fascinating destinations that hold the potential to revolutionize our understanding of the universe. While the search for life beyond Earth is still in its early stages, these celestial bodies provide unique environments that could potentially support life. In the next few years, missions like NASA's Europa Clipper and the European Space Agency's JUICE mission will collect new data on the chemistry and habitability of Europa. NASA's Dragonfly mission will explore the surface of Titan, providing further insights into this mysterious moon. Additionally, advanced telescopes like the James Webb Space Telescope and the Giant Magellan Telescope will allow us to observe exoplanets like Proxima b in unprecedented detail, potentially revealing clues about the existence of life beyond our solar system. While the discovery of extraterrestrial life is still uncertain, continued exploration and research offer hope that we may one day find evidence of life beyond Earth and expand our understanding of the vast universe we inhabit. Think you?